The examples that we've looked at so far have all been in the gas state. What if we have solids or liquids in the reaction? Here we have calcium carbonate solid decomposing to form calcium oxide and carbon dioxide, and the reverse reaction can also occur. When we write the equilibrium constant expression for this, we leave out the solids because the concentration of a solid doesn't change. The amount of solid can change, but the concentration doesn't change. As long as there is some there, its concentration is the same. If you have a solution, something dissolved in water, the concentration can change. But if you have a pure solid, it can't change. Also, if you have a liquid, the concentration of water doesn't change, whether you have a drop or a swimming pool full. The number of moles in a liter is always the same. So we leave pure solids and liquids out of the expression because they don't change, and sticking them in there would make things really difficult for no purpose. So we leave them out. So why do we leave them out? Because, basically. So let's write an equilibrium expression for this chemical reaction. So KEQ equals, we're going to take the products, concentration, and divide by the reactants. So our first product is H2O, but it's a liquid. So we're going to leave that out. Its concentration doesn't change, and so we're not going to include it. So we'll just skip that. And then we've got Cl2. This is a gas. The concentration of a gas can change because you can compress it or let it expand. So the concentration of Cl2, and that's going to be squared because of the coefficient 2. Divided by, and then we want the reactant concentrations. Well, this one's a gas, so HCl, and the coefficient is 4, so the exponent is 4. O2 is a gas, so we've got to include that, O2. And its coefficient is, its coefficient is 1, and so the exponent is 1. And there's the equilibrium expression for that reaction. Any questions?
If something is considered aqueous, what do we do with that?
If it's aqueous, then it is included because the concentration can change. It's just solids and liquids because they're not compressible, so their concentrations can't change.